Machine translation is a field within computational linguistics. It is the process of modeling natural language from a computational perspective. The use or exclusion of humans in the translation process and the integration of text or speech are the basis for MT. There are several approaches to MT. Rules-based MT converts corpora to machine-readable form. It translates using rules, lexicon, and parsers. It does not require extensive data for training. It's also easy to maintain and extend. Unfortunately, the training process for rules-based MT is resource and people-intensive, and this approach does not deal well with jargon. Historic versions of Systran and Prompt and the current version of Lucy are examples of rules-based MT. Statistical MT treats translation as a math reasoning problem. Corpora is compared to a database of training data using probability, statistics, clustering, and classification. Translations sound more natural and better handle jargon. However, dissimilar training data can lead to less accuracy. Moses is an example of an open-source statistical MT, and many commercial systems are derived from it. Others include Google, Microsoft, Abby, SDL, and Lionbridge. Neural network MT is the latest approach. It trains a neural network using deep representation learning. Many neural network MT use two recurrent neural networks through an encoder-decoder model. Compared to other approaches, there is less need for extensive domain knowledge. Performance with jargon is better, and neural network MT requires a fraction of the memory. Unfortunately, there are demanding hardware requirements with neural network MT. Training is slow, and rare words are problematic, and it is difficult to add new training data after the initial training phase. Google, Microsoft, and SDL are introducing variations of neural network MT. Hybrid MT is another approach. Historically, hybrid MT are variations that combined rules and statistical MT. Future versions will likely combine statistical and neural network MT. From a commercial standpoint, MT is applied to a large volume of content, but a relatively small number of languages. After the top 20 languages, the rate falls rapidly. Of the top 20, 11 are languages of countries officially in the EU, and 3 more hold a significant position in Europe. East Asian languages are also common. A longer-term evolution is the change in translation input language to output languages. Early translation systems were tree-like, with one input language translating into 10 or fewer output languages. Now it is a more branched, structured system, with around 6 input languages translating into 60 output languages. Ultimately, the structure is expected to be network-like, with hundreds of input languages translating into hundreds of output languages. Global demand for MT has been largely from North America, historically due to the IT sector. They are the leading adopter, and the largest IT companies are based in the US. Europe has been a distant second in demand, but has been the leading supplier of technology. This is due in part to EU-financed technology development, which has traditionally outpaced the rest of the world. Over time, however, resources have been bought by American firms who are advancing the technology. The majority of MT R&D is being conducted by research institutes and universities in 8 countries. R&D topics include statistical MT training with low quantity or quality of data and additional analytics such as semantic, context modeling, and linguistic knowledge. Neural network MT methods such as recurrent, feed-forward, attention-based, and the challenges such as rare words. Translation memories, which are databases that store units or sentences that have previously been translated. Other topics include speech and domain-specific MT. The market for MT is changing. The next 3 to 5 years will see growth in enterprise use, especially in Europe. And while Europe will continue to be important, additional advancements will likely also be from large enterprises. The demand for MT will grow in the military, defense, and intelligence sectors. MT is useful in supporting field operations. It enables communication with partners. And MT is a valuable tool in the analysis of SIGINT and OSINT. Full automation with the accuracy of human translation may not be realized in the next 3 to 5 years. And while some use cases are reaching a good enough point, more R&D is needed to advance MT for user-generated content. Areas where MT can offer the most social benefit require systems to deal with very diverse language without editing. These areas are particularly challenging for current MT. Understanding of MT and its diverse role is growing. IT firms are advancing the art of the science. Neural networks are pushing the field to allow for entire corpora to be well translated. Government and industry leaders must prepare their data in order to take advantage of these swiftly emerging opportunities.